Hello everyone, very good afternoon. I'm audible. If I'm audible, you can reply. I'm audible. Check. Please check I'm audible or not. Audible. Okay. So in the last class, we were discussing the few things. Very first thing was that the electric field lines we have discussed. I'm just summarizing this in a little fast manner. We can see the next topic today. Okay, that's a very important thing. Electric field lines, I told you it is the imaginary curve that we have to understand it. Okay, it is the imaginary curve, whatever you are putting it. Okay, so any electric field line, it is not a real curve, it is an imaginary curve. So any point charge is there, it is a positive or negative. So whenever we are drawing the field lines, those are imaginary curves going outward or inward. If positive charge, it will be radially outward, point charge. If it's a negative charge, then it would be radially inward charge is there. Okay, beta. Now that we have seen that the positive charge, this is a negative charge. So due to negative charge, radially inward, and this is radially outward. We have seen. Okay. Next is the continuous curve in the charge-free region. So any charge-free region is there, then it would be continuous. It cannot be discontinuous. Like this, I have shown you. Suppose there is a charge is there, and from that the electric field lines are drawn. So these are charge-free region, but there no other charge is present. But still, I have shown you discontinuity. It is possible or not possible? Not possible. It is not possible there. So this electric field lines are continuous curve. Beta. Okay. Tangent on the curve gives the direction of electric field. Tangent on the curve. If you see, this is the one curve is there, electric field line curve. So if you are drawing the right tangent, that is nothing else. Direction of electric field. Direction of electric field. We have seen the originate from positive charge and terminate at negative charge or infinity. So whenever we are drawing it, you will see it. We have drawn in the next slide. You can check. Okay, this is the positive charge is there. This is negative charge. So it is start from positive charge and terminates on negative charge. That you have to understand it clearly. Okay, or it will go to the infinity if there are no charges present, but it cannot be discontinued anywhere. That we have seen. Next is no two field lines can intersect each other. Why? Because at the point of intersection there would be two tangent can be drawn. If two tangent can be drawn, that means there would be two possible direction of field. That is not possible. The possible direction of electric field can be only one. That means electric field at one point would be only in one direction. I'm audible to everyone, beta. The many viewers joined little late. So if I'm audible, please reply. You can put text. Okay. Next. Electric field line cannot suddenly disappear, cannot be discontinuous if there are no charges present. Just like I have explained here, this point and the point number 2 is same. So similar, both statement is same, that you can understand it. Now, the number of field lines in a region indicates the strength of electric field. So any region is there. Very good evening, beta Chandana. So what I am saying, if a number of field lines in a region, okay, indicates the strength of field. That means if number of field line in a region is more, that means it would be more strength of electric field. That means electric field is strong there. At strong field lines, means the number of field line intensity is more in a region, that means more strong field. So we have seen this diagram that if the A region, the B region or C region, so where the field is strong, so you can see very clearly that these are exactly equal area I have taken, and we are seeing where the field is much stronger. So field at A is much stronger than C than B. So you can see very clearly. Okay. Now, next we have discussed the number of field lines related to a charge particle is directly proportional to charge Q. Charge Q. That means number of field lines, how much number of field lines are there? It is directly, we can say, number of field lines is equal to Q by epsilon naught. That means if charge would be more number of field lines will be created or related to the charge, either originating or terminating. So if number of field lines related to the point charge you are writing, that is the Q by epsilon naught. Q by epsilon naught. Q is the charge, epsilon naught is the permittivity of free space beta. Permittivity of free space. So when we are writing the epsilon naught value, 8.85 into 10 to the power minus 12 Coulomb square upon Newton meter square. Coulomb square upon Newton meter square. That we call it epsilon naught. So using this term we can get it. But we understand one more thing here. Number of field line is directly proportional to Q. That means number of field line would be more if charge is more. Or we can say if number of field line is more means charge is more, or charge is more, that means number of field line is more. So similarly, I have given you some example. Ki suppose there is a one charge is there. This is 1, this is 4Q. This is 1 Coulomb, 1 Coulomb, and this is 4 Coulomb. So if I am drawing here the 4 lines, field lines, so this would be 16, 4 times more. Similarly, I have given some examples also. Ki you can check there the another examples. Just like this is a Q1, this is Q2. Using Q1 and Q2, you can check it and you can tell what is the ratio of Q1 by Q2 magnitude. So this is the Q1, this is Q2. We have to see the magnitude there. So we can say Q1 by Q2 magnitude, that means 8 by 12. Number of field line here are 8. These are 12. So 8 by 12 means 2:3 ratio it is. Okay. Similarly, here I have given you, suppose both are positive, then also you can tell. So I have given Q1 by Q2, that would be 5 by 13. I think it is clear to everyone, beta. Now tell me please, all the viewers, please tell, it is a clear concept. What is the field line properties? Clear or not clear, beta? Okay, clear na beta? Now see, suppose this is the equilateral triangle beta. It is the equilateral triangle, and on this equilateral triangle at the vertices you can see these are some charges Q. This is also Q. This is also Q. If I am saying ki all are positive, suppose they all are positive charge. These are all are positive charge, and equal charge I am taking, and this is the equilateral triangle. It is the equilateral triangle. Now question is that ki draw their electric field lines. Draw their electric field lines. So how to draw that electric field line? You have to understand clearly first. So I am telling you very basic thing. You can see ki there would be one null point here. I told you there would be one null point here. There would be one null point here at the midpoint. This is L by 2 we are writing. It is L by 2 we are writing. So no need to write also. We know already this. We have discussed in the previous class. So this is L by 2, it is also L by 2, it is L by 2 beta, it is also L by 2. These are null points. So if we draw the lines from here, from the center also. Now the first question comes to your mind, why you are taking to the center side? Because we already know the center also field is 0. The field is 0 here. Similarly, I am drawing these field lines, this dotted lines. These dotted lines are there. Now you can draw very easily the electric field lines. So I am drawing it. This is electric field lines. These are electric field lines, beta. These are electric field lines. These are electric field lines for Q. This one. Similarly, for second Q, you can draw like this, beta. But remember, whatever number of field line you are drawing here, the same you have to draw here. Because charge magnitude is same, the number of field line would be also same. So I am drawing here. Okay, you can draw like this. Okay, this is a very simple thing. You can check it. Similarly, this is also same charge, so you will draw the equal number of field lines. These are field lines. no field line will intersect each other, and they are positive, so radially outward the field line would be. There would be radially outward field lines. This diagram is clear to everyone, beta? Yes or no, sir? Please reply. Please reply, beta. Please reply. It is clear to everyone? This diagram is clear, beta? Now similar diagram I am giving you. Similar diagram I am giving you. Similar question. Please try. This is minus. This is also minus. This is also minus Q. An equilateral triangle. Now again we have to draw the electric field lines. Can we draw? Please reply, beta. All the viewers, please be a little attentive and please reply again and again for the questions. That would be more clear to you. Okay, this is a minus, this is minus, it is minus. Same diagram, similar diagram we are drawing. So what we have to draw? Again we have to draw the field lines. So how to draw the field lines? You can check again. Again you will say this is null points are there for two charges, and this is center. Here field is 0. So I am taking this as the dotted line again. You will draw the dotted line like this. Okay, using this dotted line, now you can draw the field lines. So field line would be also similar field lines we can draw here. So you can draw like this field lines, beta. These are field lines. You are drawing it. Okay, these are field lines I am drawing. Okay, just wait. This is negative charge, so better to this arrow should be changed. This arrow should be changed. So I am just changing the arrow. You have to understand it. Okay, this arrow would be inward, not outward. This is the inward arrows towards the charge. Similarly, you can draw for this also, beta. You can draw towards charge. Similarly, you can draw here also. These are the field lines. Clear? This is the field lines we can draw it. Very, very simple. So whenever field line draw, to draw the field lines question comes to you, you have to be clear about it. Already this is a PYQ question. You have to understand carefully. Now I am taking to you the next topic, that is the important one. Try to understand that the properties of conductors. Properties of conductor, very, very important topic. Try to understand it. So till now in this chapter we have not discussed about the conductors. Now you have to understand very carefully from the daily life. We see the two types of substances there. Very first type of substance that we call it conductor. Second is the insulator. Daily life, where if the light is working, this board is working, television is working, your mobile is there, mobile is working, anywhere you are sitting in a room, then fan is working, AC is working. So there are two types of things are there. Okay, by the way, there are three types also. We call it conductor, semiconductor and insulator. For simple discussion of this topic, so we keep semiconductors separate, because semiconductor there is a separate chapter in this 12th class. We will see later. But right now we are discussing about conductors and insulators. When I am saying conductor, what is the meaning of conductor? Conductors means a substance whose conductivity is very high. Very basic definition. Or whose resistivity is very low. Whose resistivity is very low. Conductivity is very high, resistivity is low. That we call it what, beta? Conductors. Just opposite we call it insulator. If its conductivity is very low, resistivity is very high, then we call it insulator. Semiconductor are their conductivity and resistivity lies in between of conductors and semiconductors, insulators, that we call it semiconductor. But by the way, we are not discussing right now semiconductor, we will see later. Okay, now come to the point. What I am saying that conductors means the substance whose conductivity is very high. Now question comes to you, what is the meaning conductivity is high? That means they are having a large number of free charge particles. They can move from one point to another point very easily. That we call it free charge particle. But remember this thing, these charge particles are not so much free. Suppose I am in right now, there is any conductor in Delhi. So from the conductor is placed in Delhi, so electrons coming out of that metal or conductor and going to the Bombay, having Bada Pav and coming back, it is not possible for them. They can travel, but on the surface of the conductor, not outside the conductor. They can travel, but on the surface of conductor, not outside the conductor. That should be clear to you. Okay, that is the meaning of free electrons or free charge particles. Okay, now question is there, sir, why you are saying free electrons? Yes, that is also concept. Conductors can be different type. Our body is also conductor. If you are taking a one tap water is also conductor. If we taking what earth is also conductor. If we are taking metals, wires, that is also conductor. If you are taking a water and you are just making a solution of NaCl, that is also conductor, or HCl, it is also conductor. So when we are saying this thing, so there are a lot of different type of conductors are present in this world. But now for our discussion should be concentrated in a word, one particular type of conductors, we have to restrict ourselves. So we are restricting our discussion only to the metals. So that's why I have written here clearly properties of conductor, but we are talking only about metals, not any other conductor. Try to understand. So metals are there. When we are saying metal, so metal is having a large number of free electrons. Metal, if you see in the chemistry, you learn it, in metallic bonds are there. So metal ions are fixed, almost fixed in their crystal. If the metal ions are fixed, means atoms are fixed, but their few electrons are very easily available for the conduction. Okay, I am not going too much in detail about it. We will learn in the semiconductor chapter details about it, okay, how the electrons are freely available there. But right now we understand, yes, electrons are available there. So a large number of electrons, if you give little bit idea, Akshay, yes, Peter, hello, yes, please tell me, what is the doubt? Please put your doubts, I will explain it. So I am telling you that when the metal is there, so it is having a large number of free electrons. These electrons can move from one place to another place very easily. How they can move, when they will move, we will learn with the time. Very basic example. Suppose you are taking a one bulb. Suppose there is a one bulb is there, beta. It is a symbol of bulb. I am putting it. It is the bulb, and you are connecting with a battery. There is a battery and there is a switch is there. Okay. Then what is happening? Current is start to flow and this bulb start to glow. Okay. This is light is coming out of this bulb. This is a very basic thing. Okay. So this current is flowing. When current is flowing means opposite to the current, what are the electrons are moving? What is moving? Electrons are moving. So that electrons is moving from one place to another place. So that can be conductor. So what is the why here electrons are moving? Because you put one potential difference, one battery. So if you are putting any potential difference, then also the electrons can move. If you are not creating the potential difference, it is difficult to move the electrons. This is a very basic doubt comes to our mind, but this is not the situation. At any point of time, these electrons are moving randomly from one point to another point. Okay, they are in random motion, just like gases. Suppose we are sitting in a one room. This is a one room is there. Okay, that is studio room. In that studio room where we are actually taking this live class. So there the gas is present. That's why I am taking a oxygen otherwise it is not possible. Okay. So there's a gas, air is present in this room. Okay. So I am taking that air. So air particles or molecules, we can say, they are moving from one place to another place, random motion, that we learned already in the previous year in the kinetic theory of gases. So they are moving randomly from one place to another place. Similarly, in the metals also, these electrons are always in random motion. Similarly, I am not saying exact manner. Similarly, but the metal ions are fixed in the crystal. If you see the crystal, in that the metal ions are fixed, but the free electrons are moving from here to there. But now some student having one doubt. What a doubt? Beta Nandu, hello. Akshay, beta, please put your doubt. I will explain it. Okay. I am saying again. When electrons are moving from one place to another place, we are saying random motion. No problem. Very basic thing. Now, the one is doubt comes in the minds of a student sometimes. Sir, all electrons are free? The answer is no. Definitely no. Not all electrons. Just I am giving a very basic example. Suppose you are taking iron. In iron, you know Fe plus 2 or Fe plus 3, that like this. But most probably the Fe plus 2. Okay. That means the 2 electrons in outermost cell are more easily available for the conduction. Not always, not all 2. But I am just telling you, probability is there. So higher probability is these 2 electrons. But if you see the Fe is 26. Atomic number is 26. That means total number of electrons are 26. Out of that, only the 2 electrons, maximum 2 electrons are easily available. Not all 26. So try to understand. So there are 2 types of electrons are there. One is bound electron and one is what? Free electron. So bound electron do not move anywhere. Only free electrons are moving on the surface of the conductor. This line is, I think, now clear. It is clear to everyone, beta? Please reply. It is clear to everyone? Clear na beta? Okay, beta. Now we are going to see one more thing here. What is here? I'm talking about it. This is the metals we are talking about. Metals. They have a large number of electric charges, electrons free to move inside the material. Okay, it's a very large number of electron. Music, very good, beta. Other people also can reply. It is clear to you or not. So they have a large number of electrons. Next is when some charge is transferred to the conductor, it radially distributed over entire surface of the conductor. What is the meaning of this? What is the meaning of this line? Try to understand. I am taking to you the next point. Next slide. I will explain it. Suppose this is the one conductor. I am taking very simple surface. Spherical surface. It's the spherical metal surface. It is a spherical metal surface. Try to understand it. So it is a metal. It is made up of metal. And what is happening here? It is a metal means large number of free electrons. If you are putting at this point some charge Q, think carefully. If you are putting the one charge Q here, so other surface there is no charge. Only this point you are putting charge. Very good. If the charge remain at this surface, that means this charge is creating its own field, some aura here. Yes. So at this point, the aura would be more. Try to understand it. Now, what is happening here? If you see the nearby point, so here field is more, here field is less, here field is more less, here would be minimum. Like this, the field is more like this. It is happening. Now, due to this, what is happening? This nearby point, if you are taking this point A or you are taking B, this is C, this is D. So from A, the field would be more. That means here the free electrons are there. If electron is there, on this electron, due to this positive charge, field is outward. But this electron is negative charge and field force would be in opposite direction. That means this electron start to move this side. Similarly, this electron also moves from this towards this side. Same electron, this electron, these electrons are start moving like this. Now think carefully. These electrons start moving towards this charge. Now what is happening? Common sense. Put it outside. If any electron is moving from A to this Q, then it is making here charge. How charge? Because initially it was neutral. And initially neutral, if you are taking negative charge, then it becomes positively charged. That means now A point become positive. Similarly, B become positive. And similarly manner, after some time, you will see, after some time means after fraction of second. This whole process completed in fraction of second. Whole process. When you put charge at any point on the conductor, this is going to distribute everywhere. Now you will say, why distributed? This was positive, then A also become positive, B also become positive, C also become positive, C, D also become positive, and this is distributed. Now there the one confusion comes to the student's mind sometime. Okay, sir, this is uniformly distributed or non-uniformly distributed? I am repeating again, it is uniformly distributed or non-uniformly distributed. This question can be answered not right now, but with the time we will see. I am repeating again, if it is uniformly distributed, for now I will say, if it is a spherical surface, then it is uniformly distributed. That means everywhere the density of charge would be same. The density of charge would be same. Everywhere the charge density would be same. But if it is not this sphere, if suppose this is any irregular surface I am putting it, then if you are putting the charge here Q, okay, you are putting the charge here Q on this surface, then this is also distributed everywhere after some time, but not uniformly. It is non-uniform. It is non-uniform. It is non-uniform. This should be clear to you. It is non-uniform. This will be distributed like this, uniform. It is not. It is uniform, beta. After some time you will see the charge is like this. So this is non-uniform. It is uniform. It is uniform. So this thing is we call charge distribution. So whenever you are putting the charge on the metal conductor any point, then it is distributed on the surface. Now the one question also comes to the student mind. But before that I will ask you, it is clear to everyone, beta? If it is clear, put it your reaction, beta, in the chat box. Now I am repeating again. Sometimes the one student also asks this doubt in my class, कि suppose you are not putting such a charge inside on the surface. By putting some injection or something, it is a metal solid sphere. I am saying metallic solid sphere. Metallic solid sphere. So if I am saying this is a metallic solid sphere, and this metallic solid sphere, you are by putting some injection and you are putting some charge, this is the charge Q. Okay, here you put it inside. Now question is that what will happen, sir? This charge would be also distributed or not distributed? What is the fake, beta? Texas John, what you are going to see? If you are having any query, you can tell. So I am saying this is the one metallic sphere. In this metallic sphere, if you are putting the charge Q at the center, so what will, or center or any somewhere, not necessary at the center, anywhere you are putting inside it. So question is that what will happen? This charge would be remain inside or it will come on the surface. So answer is again come on the surface. How? Listen carefully. Due to this charge, again the field lines will be like this, radially outward like this. This field line would be like this. Yes. Now see clearly, there are also electrons. There are also but I'm not understanding what you want to say. Some college get NIT seat and rest are waste. What? I'm not understanding, beta. This class for the NEET, okay, NEET preparation, we are putting it. This is for medical students. I'm taking class, okay. So very first thing is this. You should be clear. Okay, this is for medical students, and for the NEET preparation 2026. This is the we can say one course, basic course we have started. So please put your query properly. So I am saying this is a clearly, okay, this is the field lines are there, you can see radially outward, but on the surface there are free electrons. Now think carefully, there are free electrons are there. On these free electrons, what will be the direction of force? Opposite to the field. Opposite to the field means towards center. Think carefully, this is towards center, this force is towards center. That means this electron, free electron from the surface will start to move towards the center or wherever the charge is present. So they will start to move towards the charge. When they will start to travel the charge, then what they are leaving behind? Here positive charge, positive, 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 positive. And finally, if you see here, this will be neutralized. So what is happening? This is converting into this part. Now this is again the charge comes on the surface. Charge come on surface. Now again question is there. I am asking to you. Please tell me, this would be uniform or non-uniform? This charge distribution would be uniform or non-uniform? Please tell me, beta. I am asking to you, uniform or non-uniform? You will reply. Okay. Uniformly or non-uniformly charge distribution of charge. Tell me, beta. Distribution of charge. Okay. Tell me your answer. What is the answer? Yes, Zaranya beta. Very good. Answer is clear. That is the uniform. It is uniform. It is not non-uniform. This is incorrect. This is correct. So this is uniformly distributed charge because this is a sphere. If it is not a sphere, if any other surface, then also the same thing will happen. Not necessary. This is any surface is there. If you are putting here charge, it is a solid metallic sphere, solid metal body. If you are putting solid metal body, then what will happen? Then what will happen? Very simple. You will see this charge will be coming on the surface. After this, try to understand this is same. You have to assume. I'm not making exactly same, but try to assume it is the same. So what will happen? This charge will come on the surface. Definitely it is non-uniform. Non-uniform. It is a non-uniform. It is non-uniform. But this charge would be also Q. Remember this thing, if this charge is Q, this is also Q. This charge is Q, then this is also Q. The value would be same. Why value same? We already know charge is conserved quantity for an isolated system. Charge is not going to change. Charge remain conserved. Charge remain conserved. Clear or not clear, beta, everyone? To everyone, please reply. It's clear? This concept is clear, na beta? Okay. Net charge inside the conductor in electrostatic condition is 0. Next property, just now I have explained, the net charge inside the conductor in electrostatic condition is 0. Now I explained just now, if you are putting it this case, if you are putting inside also, then this is going to happen. Now any other student can say, sir, not understood. Suppose this is any conductor, any general conductor is there, and in this conductor you are putting one cavity, or not necessary ki this is the cavity, don't think it is a any symmetric shape, any general cavity. So I am telling you clearly that this is beta cavity. Just be focused. This is cavity. I am telling you this is cavity. Okay, cavity I am taking it. And this is a metal. So try to understand it is a metal body. This is metal body. It is a metal body, it is a cavity. That means this other part is solid and this is only hollow. This inside part is hollow. If any student say, sir, we are taking one charge Q here, one charge Q here, then what will happen? Then what will happen? This charge will be distributed on outer surface. You are seeing little bit earlier. Then here also it will happen or not happen? Definitely it is going to happen. How? Focus. I am telling you clearly that if we draw the field lines, if you draw the field line, you will understand. Suppose this is a point charge. So from that the field lines are coming like this. Now these field lines I am drawing it. These are the field lines. If you draw the field lines, try to understand it. We already know one thing. That the field lines are continuous curve. They originate from positive charge and they terminate on infinity or negative charge. So definitely these field lines are terminating here. That means there should be negative charge. At the negative charge. Now question is that how much negative charge? Equal amount. How much negative charge? Equal amount. That means this is a minus Q. This is minus Q. So this is plus Q. This is minus Q. That are the charges. So plus Q charge, minus Q charge is coming. Now the question again comes to you, okay, sir, how it is possible that minus Q charge is there? I already told you very basic thing, beta. This was the positive charge. And from that the field is coming. So it is attracting the electrons. But from where? From the surface. So from the surface, the actually electrons were moving like this. These electrons were moving like this. So when electrons are moving towards it like this, then what will happen? They will make a negative charge surface on the cavity. But on the outer surface, what they are making? They are making a positive charge. They are making a positive charge. They are making a positive charge like this. Okay, so I am repeating again. I am making again diagram, clear diagram that you have to understand it. Please focus. Suppose initially I am trying to make the similar diagram. If it is not similar, assume it similar. Okay, this is the one cavity here, and in this cavity I am putting a one charge. This is the point charge, positive. Then if you are drawing the field lines, you will see that there is a negative charge appear on this surface. Again, how much? Minus Q. But on the outer surface, this would be plus Q. So on the surface, if you see, this is the charge. This is the case. And here you can draw the field. Clear? This is the negative charge. This is charge is coming distribution. This line is clear to everyone, beta? Very basic thing I am asking it. Clear to everyone? Okay, how to write the charge? So if you see here, inside the conductor, again I am asking the same question. Inside the conductor, what is the net charge? 0. This is plus Q, this is minus Q, net becomes 0. So whatever charge remains, it remains only on the outer surface. It remains only on the outer surface. So whenever you are putting any charge, it only remains on the outer surface of conductor. Inside the conductor, net charge is equal to 0. Net charge is equal to 0 in electrostatic condition. Clearly I am talking about it. not in any other situation. I am talking about electrostatic condition. So the electrostatic condition, the net charge is equal to 0. But it is clear to everyone? Sharanya, Music, Nandu, Chandana, Akshya. Clear beta? Or other viewers also you can reply it. So this is a very basic situation I have explained to you. Now from this we understand one more thing. What is that? Please focus. I am telling you the how to draw the field lines. This is a positive charge, this is negative. So from here the field lines will be like this. Now try to understand. This is the field lines. I am drawing it. These are the field lines. I am drawing the field lines, beta. These are field lines. This is electric field line I am drawing it. This is a very basic situation that you have to learn it. Already PYQ questions related to the cavity questions also there. So you have to be clear about it. What is the meaning of cavity and what is the meaning of field lines for a conductors? Clear beta? Now one more thing comes to our mind. Ki, sir, why are you not drawing the radially outward ekdam straight lines? Why are you drawing this curvilinear type line? Why you are drawing this curve type lines? So I am repeating again, try to understand it. Suppose I am drawing, this is the one, any conductor. Very basic, this conductor I am drawing to here. Okay. And on this conductor, suppose the charge is there. Same charge I am putting here. Suppose this is the same charge here. This is charge is Q. If this charge is Q, now question comes to our mind, ki suppose on the surface you are drawing any this field line. So what is the problem? Suppose this is a field line beta. What is the problem here? Any problem, sir? Why you are not drawing like this? Why you are drawing like this? So there is a problem is there. What is the problem? Please understand. If you are drawing this field line, that means that field line is having a two component. Now you say, sir, field line. What is the meaning of component? Yes, field line does not have any component. Field lines indicate the direction of field. So this is the electric field actually also. So this is the electric field also. That means this electric field is a vector quantity. So I can draw this electric field into two directions. Now you will say, okay, so your choice, you can do it. Vector, we can, no problem. So there are two directions. What are the two directions? Perpendicular to the surface and along the surface. So I am writing here, there are two fields. That is the normal to the surface. That the another is tangential to the surface. So there are two directions beta. One is tangential direction, one is normal direction. One is normal direction, one is tangential direction. Very good, no problem, sir. So what is the meaning of this? Yes, meaning is there. We know this on the surface. Now positive charge is there. Focus. Then what will happen? This positive charge, or we can say free electrons, whatever it is there. So due to this tangential field, due to this tangential component of field, what will happen? It will start to move. It will start to move. So this electron will start to move on the surface because their tangential component is present. Now think carefully what we are studying, electrostatics. What we are studying, electrostatic. In electrostatic condition, what is happening? Charge should be at rest. But you are saying that their tangential component is present. Due to this tangential component, the current will start to come on the surface. That means there is the one surface current is there. But we are studying surface current. The answer is no. We are talking about electrostatic condition. We already told you this chapter's name is electrostatic. We are not interested in the motion. That means it is not possible in electrostatic condition that the field line is at any angle other than 90. That means for conductors, it is a very, very important property. Try to understand it. Very important property for conductor. The field lines are always perpendicular to the surface. Always perpendicular to the surface. That's why I have drawn this. So you can check here, these field lines are always perpendicular to the surface. You can find it. This is the electric field lines are perpendicular to the surface. Not only here, inside also cavity you can check. This is perpendicular to the surface. This is the perpendicular to the surface. I think it is clear to everyone, beta. Bhuvnesh. Okay. Sharanya. Music, Nandu, Akshaya, and Chandashri, and other viewers also, you can reply. It is clear or not clear, beta? This is the meaning. What are the meaning of electric field lines? Okay. Now, next property we are going to learn it. What is that? Inside a conductor, the electrostatic field is 0. Just now I told you, the net charge is 0, the net field also 0. So it is not going to change. That's a very important property. At the surface, the charged conductor electrostatic field must be normal to the surface at every point. Just now I explained, it is always normal. Next point. The interior of a conductor can have no excess charge in static situation. In electrostatic situation, there cannot be any excess charge. It would be net charge 0. I explained it in the cavity also. Electrostatic potential, we will learn with the time, yes, I am explaining it, is constant throughout the volume of conductor and the same value on its surface. Just remember for now, in electrostatic situation, what happened, the potential is everywhere same. Now you will say, sir, we have not studied electric potential, so please don't explain. I am telling you 10th class thing, you will remember. You know the battery is having a potential difference. Due to potential difference, when you connect with the wire, the current start to flow. Wire means conductor. So whenever any conductor across any potential difference across the conductor, I am repeating again, if there is any potential difference across the conductor, then there would be some current. There would be some current. But we already told you this is electrostatic situation. That means we don't want any current. The current is 0 here. So current is 0. That means charge should not move. If charge should not move, that means potential difference should be 0. Potential difference would be 0. Difference means between any 2 points, 2 different potential. If potential difference is 0, that means both points is having same potential. So in electrostatic situation, all points may be inside or maybe outside. Not outside means on the surface, inside or on the surface, each and every point in the conductor have the same potential. Now this line is clear. This is the same potential. Next, electric field at the surface of charged conductor is sigma by epsilon naught. I will explain it. I am not driving right now. We will drive in the coming classes. But for now, we will understand, we will remember it. Okay, if any field is there, that field is equal to sigma by epsilon naught and n cap. Now you will say, so what is the meaning of n cap? N cap means normal to the surface of conductor. Normal to the surface of conductor. Sigma is the surface charge density. I will explain surface charge density. There are different type of surface charge densities are there. Try to understand. There are 3 types of densities are there. I am explaining it. Whenever we are saying density beta, there are 3 kinds of density. What are those 3 kinds? Very first is we call it what? Linear charge density. Linear charge density. Linear charge density. Next is aerial charge density. Aerial charge density, or we sometimes we call it surface charge density. Surface charge density. Similarly, we are writing here volume charge density. Volume charge density. Try to understand it. When I am saying linear charge density, it is denoted by generally lambda. Generally. Surface charge density generally denoted by sigma. Volume charge density divided by rho. Okay. I am writing it linear charge density lambda. Lambda means actually charge divided by length of the conductor. Charge divided by length of conductor. Similarly, I am talking about areal charge density or surface charge density. That means sigma. Sigma is equal to charge divided by surface area. Charge divided by surface area that I am talking about. Similarly, rho. Rho is equal to charge divided by volume. Charge divided by volume. This is the surface charge density we are writing it. So linear charge density, surface charge density, volume charge density, we are writing it. So here I am talking about surface charge density. Now you will see, sir, why you are taking surface charge density? Because net charge remain on the surface of conductor only. On the surface of conductor, that means charge, total charge divided by surface area, we can get the surface charge density. If it is uniformly distributed. If it is not uniformly, then surface charge density everywhere would be different. How to calculate? With the time we will learn it. Okay, right now we understand this point. This is the sigma by epsilon n cap. Okay, next point. Net field, net charge inside the cavity is 0. I explained to you, net charge also 0, net field also 0. Electrostatic shield, not fielding, this is a actually mistake. This is shielding. This is the one point I am going to explain it. Electrostatic shielding, beta. This is a point. It is wrong. Okay, we have to understand it. It is the electrostatic shielding we are talking about. So electrostatic shielding, shielding means to protect. To protect. When I am talking about it, to protect means you want to protect something from the external or outside field. Outside electric field, we want to protect something, somebody. So somebody is there, we want to protect from outside field. Then how to protect? For that, there is one concept we call electrostatic shielding. Now please understand what I want to say. I am taking to you the next point. Here, take. This is the point is here, beta. Suppose this is a conductor. This is a metallic conductor. It's the metal. It's a metal sphere. I am taking it. It's a metal sphere. Try to understand. It's the metal sphere is there, beta. In this metal sphere, what you are doing? Suppose external field is coming. This is the external field. This is the external field is coming, beta. It's the external field is coming. This is a neutral initially, if I assume it. This field is coming. We know the field can never be discontinuous. Field line is always continuous. Either it will terminate on the negative charge or at infinity. Definitely there is no infinity. But it can terminate on negative charge. Yes. Because think carefully from where it is coming. This field is coming from where? Positive charge. So there is a positive charge, then it will terminate on negative charge. That means here should be some negative charge will start to appear on the surface. Okay, that means this will terminate on the surface. This will terminate on the surface. It will terminate on the surface. This side and negative charge start to appear. If this side and negative charge start to appear, so no need to say that this side would be positive. Now question comes to you, sir, why positive? If left side is coming negative, then why right side you are saying positive? Beta, this overall is neutral, na? If this side is negative, then this side is positive, then only it would be negative. Oh, sorry, neutral. Then only it would be neutral. So this is negative, this is positive, total becomes neutral. Now I am saying from this surface also the field line will go like this. The field line will go like this. These are the field lines. Clear or not clear? If this is a metal sphere is there, this is going to happen, outside field is coming, this is the field going, but no field line will enter inside it. Already P by Q. Already this question is P by Q. Clear or not clear, beta? Please reply. Please reply. It is clear to everyone. If any conductor is there, then this is going to happen. Very good, beta. Saranya, Gayatri, very good. Now try to understand. Now if I say, sir, this is not solid sphere, there is a one cavity also present. Take it. Suppose this is a one sphere and there is a one cavity is there. This is the cavity. I am telling you it is a cavity. Cavity. And any field is coming from outside. This is field is coming, beta. This field is coming. This is field. External field is coming. This is the external field is coming. Now question is there. This field is coming. Now question is there. What will happen, sir? Again, this is the metal sphere. Metal body. If it is metal body is there, definitely free electrons are there. So this is a field is coming from this side. Field is coming means this side is positive. So it will attract negative. So here the negative charge start to appear. That means suppose this is a minus Q charge is going to appear. So this is positive charge, this is negative charge. The field lines will terminate on the negative charge. Field line going to terminate on negative charge. If this is minus Q, no need to say, this side positive Q will come. So again the field lines is going like this. Going like this. Field lines is going like this. Field lines is going like this. This is the field lines is going like this. This is the plus Q. Very basic. Now if you understand the situation, now very first question comes to you, sir, you have not drawn any field line inside the cavity. Yes, because I told you already, the charge appears on the surface of the conductor, not inside the conductor. So net charge inside the conductor should be 0. Net field should be 0. That means no field is entering inside this cavity also. Even cavity is present there, still though no field is entering. That means if you are sitting inside this cavity or any body is not present here inside the cavity, it would be protected. It would be protected or shielded from the external field. It would be protected or shielded from the external electric field. That's why this phenomena or this process we call it electrostatic shielding. This phenomena or this situation or this process we call electrostatic shielding. I think this is clear to everyone. This is we call electrostatic shielding. Please reply. Please reply. This concept is clear to everyone. Gayatri, Sharanya. Other questions also, please reply. It is clear to everyone. Gayatri, very good, beta. It is clear. So when this concept is clear, now we have to understand few more things. I am taking to you back in the situation. Please understand. This we have discussed. All points is clear. Now take to the next point. These are few more properties related to the conductance only. So we are going to explain these properties also. Now free electrons form a kind of gas. They collide with each other and with the ions move randomly in the different direction. I already told you inside the conductor there are a large number of free electrons. They are moving randomly. Randomly when they are moving, so they are making collision with other electrons also and with the ions also. What are the ions? I told you ions is having positively charged atoms and they are having bounded electrons also. I told you already, not all electrons are free. Not all electrons are free. Try to understand it. This is the very basic that we have discussed. Okay, now try to understand second. In external electric field, they drift against the direction of field. Yes, whenever you are putting any external field, the electron is negatively charged, then they will start to move in opposite direction, not in same direction. They will start to move in opposite direction. Next, the positive ions made up of nucleus and bound electron remain held in their fixed position. I told you only electrons start to drift, not the positive ions and electrons. Now still these 2 points are not clear to many students. I am explaining again. This is the basic concept of the conductor. Current electricity chapter. Suppose this is the one conductor there. This is a conductor. And you are putting any external field. That means you are putting any external potential difference. Whenever there is potential difference, there would be one field inside this conductor. And this field is E. This field is E. Why? Because this is positive, this is negative. That means this is positive charge and this would be negative charge. This is positive charge, this is negative charge. Then from positive to negative there would be field. From positive to negative there would be field. Okay. But for now I am saying that this switch is open. That means no field. There is no field if I say this switch is open. Switch is open means no current is flowing. Now please understand. Initially without this all setup, without this external battery or potential difference, still the electrons are moving randomly like this. Randomly they are. Now question comes to our mind, sir, what is happening? This is the electron, okay, but you are making this is the direction of motion of electrons. This is direction of motion of electrons. Now question comes to our mind, sir, how it is possible that this electron is moving in this way? Yes, it is moving. Because when electrons start to this point, suppose this point I am saying that this point is A beta and it reaches to the B or C or D or E and or F. These are different points I have written. When it starts from A, it reaches to the B, there the one collision occurs. What occurs? Collision. So this start move from here and at B the collision start to occur. When collision is there, it changes its direction. Again at C there is a collision, again it changes direction. At D again is a collision, it changes its direction. At S or E also there is a collision, it changes direction. So this is the motion of electron. It is not moving in a straight line, it is moving from here to here like this. No. Randomly it is moving. This concept is clear, beta? Keshav, Gayatri, Saranya, other persons also in the chat box, please reply. This concept is clear? This is the random motion without field also. Okay, now listen. If any external field is applied, means now battery is connected. Battery is connected means switch is on. Switch is on means there the field is present. Now field is present, that means now this electron is not moving in this direction. It will move again randomly, but it will start to drift opposite to the field. That means it will start to drift like this. Drift like this. Like this. It is moving, drifting towards left. It is drifting towards left, beta. Drifting towards left. This is going to happen. This thing in detail we will study in the current electricity chapter. Very basic thing we will start and we will discuss this in detail. So there the one drift. Drift means opposite to this direction of motion. So this field, there the one drift. Drift is there. Opposite to this. So there the one unwanted distance we are checking it. So this side is a distance. Suppose this x is coming, that we call it drift of electron. That I am saying x is equal to drift. Drift of electron. Okay, drift of electron. That is coming to you. That we have to understand it. That should be clear to you. That's the meaning of drift. Understood or not understood, beta? But other bound ions or bound electrons remain fixed their position. They are not going to change. This is happening. Now this concept is clear. Now I am taking to you this part. Now you understand what is the point number 2, point number 3. What is happening in external field? They drift against the direction of field. This is the meaning of drift. Second, the positive ion made up of nucleus and bound electron remain fixed in their position, that is not going to change. Good. Next, in electrolytic conductors, charge carriers both positive and negative ions, but in the situation in this case more involved movement of charge carrier affected by both external field and chemical forces. In the battery we will learn it. What is happening? You know already in the battery in the 12th class there is a one chemistry, there is a one chapter electrochemistry. In electrochemistry you will learn in detail what is happening. There are electrolytes is there, electrodes are there, and due to some chemical reactions there is a one ions start to move positive negative to the opposite electrodes, and they are making a potential difference, they are creating a potential difference, and that we call it EMF. We will learn in the chemistry, then in the physics. For now I will just ignoring this in much detail because you have to understand the chemistry behind it. Okay. Now, whatever be the charge and field configuration outside any cavity in the conductor, try to understand it. Any cavity inside the conductor there is a cavity, but outside the conductor whatever be the charge or field, any charge or field configuration, it does not matter, remain from outside the electric influence of field inside the cavity is always zero. That means inside the cavity it remains unaffected and net field inside the cavity remains zero. It is not going to be any field there. Next, known as electrostatic shielding, not fielding, beta, it is the wrong, it is a typing mistake, just correct this. This is the electrostatic shielding, please understand it. Okay, electrostatic shielding, and this effect can be made use in the protecting sensitive instrument from the external influence. Anything you want to protect, you can keep inside the conductor, inside the cavity, you will be protected from the external field. Whatever huge amount of field is there, whatever the charge is there, you will be protected from the external field. I am giving you one more life example, you have to understand it and you have to use it in your life also, daily life, it will be useful. Understand what happened. This is a monsoon time going to start now. In this time whatever happened, there are a lot of clouds is there, rainy season is there, and lightning also there. So due to lightning in India every year hundreds of people died every year. I'm not talking about any we can say houses or any kettles, how much it destroyed. No, I'm not talking about any plants or trees. I'm talking about human life. Hundreds of human life is going to affect every year. Every year, this is a repeated phenomena. Every year this is going to occur in India, but we can be safe ourselves. So whenever any lightning is there, so from lightning what is happening, I am explaining you a little bit. In lightning situation, there is the one, we know this is the clouds and this is the earth surface. This is the earth surface, this is the clouds are there, and the clouds are moving, and due to their rubbing, due to the friction, there is the one charge coming on the clouds. Generally it is a negative charge, sometimes it's a different type of cloud, there can be positive, but I am taking a negative charge. Is there any charge is there? This earth, we are taking this earth surface, we assume it neutral. This is a charge, this is neutral. When this charge is there, more and more charge is coming there, then what will happen? There is a potential difference start to occur, and due to this potential difference, what is happening? There the current will start to flow, but you will say between earth and clouds there is the air. This is the air, it is the air, and air is a bad conductor of electricity. It is a bad conductor of electricity, means it cannot allow the flow of charge. But up to when? Up to when? This is the very important situation, try to understand it. When we say anything in the life, in the nature, having a certain limit, up to that they bear. If you are putting more than it, definitely it is going to, what is happening? It is going to destroy, or it is going to change its nature. So this is up to certain level, certain potential difference, this air remain what? Insulator or non-conductor. That means no current will flow. But when potential difference become too much high, then this current start to coming to the ground. This charge start to moving towards the ground very fast manner, means in fraction of second, a very huge amount of charge is coming. That means very high current as it is, that is happening, that we call lightning is there. Okay, that is a very simple thing we are doing. Or in this lightning, the huge amount of charge is coming to the ground. Okay, if any body is there in the ground, suppose there is one tree is there on the ground, or any house is there in the ground, if we are digging in ground, so anything is there, it is going to destroy it, because a huge amount of current is coming, it will pass through it and it will be going to destroy. But so better is whenever the lightning is there, be inside the building. Okay, don't stand nearby or under the tree, because they are more available for the lightning. Don't be nearby the any pond or water body. Keep yourself away from them. Keep yourself away from the any electrical lines also there. Any electrical line, supply line is there. Okay, transmission line is there. Keep yourself away from them. That is also very important thing. But if suppose you are driving on a road and there's a rain is there, or maybe lightning is about to come, so stop your car, but be inside the car, not go outside the car. Now question comes to you, sir, it is a conductor, it is a big problem. Just listen carefully. Suppose there's one car is there, you are sitting in a car, it is a car is there, and you are inside the car. What is the car? Metal body. Metal, and you are sitting inside it. That means this is the conductor and you are sitting inside the cavity. You are sitting inside the cavity, and we know outside whatever may be the charge, how much huge does not matter, how much big value of field does not matter. What is going to happen? No charge will enter inside the cavity, no field is going to enter inside the field cavity. That means the inside the cavity, whatever body is there, it would be protected from the external field. That means no field is going to enter. That means this body remains protected, it is not going to destroy it. Understood? Clear beta? Cherry Sanu, Saru beta. Hello, you can put your question beta, or anything you want to discuss, you can put it. Anything up to here it is clear. So in the lightning time is there, if you are inside the car you are driving, then be inside, don't come out of the car, but put your engine off and set it. Okay, now it is clear to everyone. I'm keeping today's class up to here only, this topic. In next class I will explain you very important thing, that the electric flux, and we will learn electric flux and Gauss law in detail. But please tell me first your reaction, then I will bind up the class. Kaushik, clear? Other person also put their reactions, whoever inside the class. Vamsi, clear beta? Class is clear. Gayatri, very good beta. Very good. If you like the class, please share with your friends and classmates and like it. Okay, comment it, and thank you so much. Good evening. And you can, after some time, you can join the chemistry. Thank you so much. Bye bye beta.